If you want to fly by the book, this is the book, Stick and Rudder by Wolfgang Langewiesche, published in 1944. This is the seminal reference work on flying an aeroplane, and it has some interesting things to say about the rudder. Chapter 11, the rudder. The important thing to understand about the rudder pedals is that they are unnecessary. Like your wisdom teeth, they serve no very good purpose but can cause much trouble. The aeroplane needs no rudder pedals. It should have no rudder pedals. In all probability it will have no rudder pedals 10 years hence. Now, the author's obviously trying to make a point there, and of course we know that 70 years on most aircraft still have rudders and they're still controlled in exactly the same way as they were in 1944 by a pair of pedals. And obviously throughout the rest of this book he makes many references to the uses of the rudder, but I think the point he's making is that the rudder is essentially, rather than being a primary flight control as such, its purpose is generally to make up for other deficits in the design of the aircraft. And indeed, if you learn to fly in the UK, you very likely studied this book, The Air Pilot's Manual Volume 1, used to be called Trevor Tom Book 1, which points out that although the rudder can yaw the aircraft, that's not its primary purpose. Instead, its primary purpose is to prevent unwanted yaw in many different situations. Now, I made a previous video about why we need a rudder on the aircraft, and you might want to go and review this if you haven't watched it already. But today we're going to look at three particular rudder pedal systems for Flight Sim. I'm using Flight Sim 10 here, and the systems we're going to look at are broadly representative of the, I suppose, low, middle and high end price brackets. So the systems are, at the low end we're going to look at the Cytec ProFlight rudder pedal system. Then we've got the MFG crosswind pedals representing the sort of mid-range controller, and then representing the high end we've got a set of pedals from FlightLink. Now the FlightLink pedals, these are actually the anti-torque pedals intended for helicopter control. FlightLink do a system called RCS, which is the rudder pedal control, which I don't have, but the only practical difference is that the anti-torque pedals don't have toe brakes. But I'm only going to look at the rudder control itself in this comparison, so the lack of toe brakes is not relevant, shall we say. The most basic need for a rudder is to negotiate the takeoff. Even in still air, the aircraft will tend to swing under the influence of prop effects, usually to the left, but here we have a crosswind from the right and the aircraft tends to weathercock into the wind, so we need to be pushing on the left rudder to counter that swing. And we don't need much finesse because we're travelling slowly. We need fairly large control inputs to have any effect, and we're limited here only really by the amount of rudder assertion available in the particular aircraft we're flying. Now you've got to understand, if it was in the real world we might have much more inconsistent conditions than this. We'd probably have gusting, and if you're flying with real world weather you will have that, so you do need to be fairly on your toes, quite literally, to finesse those rudder inputs. But by and large we do need assertive inputs, and all the controllers we're looking at here can handle this really without any problem. Once we're airborne we still need a bit of right rudder to counter that left turning tendency, mostly at higher power settings, so during the climb out generally. Once airborne, the challenge is to make coordinated turns. In real life we know when a turn isn't coordinated because the aircraft slips or skids, and we can feel that because we get pushed either into or out of the turn. In the sim we've got a balance ball usually that shows us this, but otherwise it's actually quite hard to notice in many aircraft. Now we're going to flip over into the default FSX glider to check this out, because the effects of uncoordinated flight are much more obvious in a glider. What we're looking for here is adverse yaw, which is a secondary effect of the aileron control. Now this is caused by differential aileron drag, and you can see it if I rock the wings here just by using the ailerons. You should see that when I bank to the left, for example, the nose initially yaws to the right and vice versa. After that initial yaw, the aircraft starts to turn, and of course it continues to turn once we've centered the ailerons. Now if you look at the balance bore, once the turn's established, you'll see we're still out of balance, so we do need to hold a bit of bottom rudder to keep it balanced in the turn. Again, you can check out my previous rudder video if you want an explanation of why this is. So flying the glider is a great way to practice coordinated turns. What you want is to make sure the aircraft rolls pretty much around the longitudinal axis without any initial yaw as you enter the bank, and this requires smooth and precise rudder control to compensate for that adverse yaw. You can practice this by putting the nose on a feature on the horizon and trying to keep it there as you roll into the turn. The nose should stay pretty much where it is until the bank's established, and then of course it starts to move into the turn, and this takes a bit of practice to get right. Now you might argue that flying uncoordinated in FSX isn't really worth bothering about unless you're flying something like the glider where the adverse yaw is really obvious. So in other words, why bother, especially as we can't feel those slips and skids like we would in real life? Well, in principle at least, sloppy and uncoordinated flight is less efficient, so you know, if you're really going to be picky about it, you should find that your fuel economy suffers. But there are other circumstances where coordinated flight is more important. So here we are in the Twin Otter. We're going to just look at a situation where it's important to make coordinated turns and hence to be able to get precise rudder control. We're in the Twin Otter overhead, stowing away, and we're going to practice hand flying some timed rate 1 turns. These are the kind of things you need to be doing to fly instrument procedures by hand. We're level at 3,000 feet, 140 knots, and we're on an easterly heading. As of now, we're hand flying. What I'm going to do is, to time the turns, I'm going to use the countdown timer on the ADF radio. So we're going to press flight time, elapsed time, hold, set, reset until we get a flash, and then we can dial in 30 seconds, which is going to give us a 90-degree turn. So we've got that dialed in. So we've got good sight of the airport now. We're going to turn onto a left downwind, which is a right turn, and I'm going to do that right now. So the first thing I do is start the timer, and at the same time start the turn, bank it to 20 degrees. I'm going to try and maintain altitude, not going to worry about the speed, let the speed sort itself out, looking to maintain that bank, trying to keep it coordinated with the rudder. I need a bit of practice with this, holding the bank. Then we're just going to hold it there, we're not looking outside necessarily, we're just looking at the AI. There's the timer, so we roll out smoothly. And we should find ourselves on a southerly heading. Well, we kind of undershot that, but that's down to my ineptitude, I think. Let's have another go at that. And the field's just off to my left, so we make a left turn, we should be heading right down the field. Same deal. There's the bank. Coordinated turn. Holding it there. Altitude's good. Bank steady. There's the timer, so we're going to roll it out smoothly. And we've undershot that a little bit, but we're not too far off. So there it is. That's one situation where it's important to make smooth, precisely coordinated turns in order to get those timings right. Maybe the Twin Otter is not the best aircraft to demonstrate this in. It doesn't need a lot of rudder to keep its turns coordinated, and in fact in real life you'd have the yaw damper on, which is pretty much an auto rudder anyway, but that's the general principle. Practicing coordinated turns really shows up the differences between these controllers. The Cytec has a real disadvantage because it has a distinct centre notch that you find yourself braking in and out of, especially while trying to sustain a well balanced turn, and neither of the other two controllers has a notch in the centre, and so each of those allows much finer control around that centre position. There are ways incidentally of removing that Cytec centre notch, so if you want to Google that you'll find plenty of instructions on how to do it, and as far as I can tell the pedals don't have a dead spot in the centre like the Cytec yoke does. As for the other two controllers, they both give excellent fine control, both very progressive, but they do feel quite different. Now you might think a set of rudder pedals is a pretty simple control, but of course nothing's ever as simple as it appears. All the devices that we're looking at here do pretty much the same thing, which is we push on one or other of the pedals and that moves away from us, and that linear motion is translated into a rotation of a potentiometer. Actually in the crosswind pedals it's not a potentiometer, it's a digital Hall effect contactless sensor, but same deal. But that said, there's two separate but equally important factors that we do need to consider when evaluating a set of pedals such as these. That's the mechanical feel, how it feels to actually operate the controller with your feet in this case, but also the electrical output characteristics, and by that I mean whether the output is, how the output varies with that mechanical movement, whether it's linear or in some sense non-linear. As far as the mechanical feel goes, although each of these devices uses a linear spring of some sort to create the tension, they feel quite different in operation. And in fact, if you measure the forces required to move these pedals throughout their range of movement, you'll notice two things. There's quite a variation in the amount of force required to move the pedals, but there are also differences in how the amount of force required varies throughout the range of deflection, if that makes sense. And if you plot these forces on a graph, you'll see that the Flight Link and the MFG pedals are quite similar in that they're pretty much linear in the feel throughout the range, whereas the Cytec pedals appear to have an exponential curve. In other words, they get stiffer towards the extremes of the range. So the further out you push them, the harder they get to push. Now I think the MFG pedals are too subtle to be measured so crudely as this, and in fact among these three sets of pedals, the MFG crosswind pedals are unique in having a mechanical profile that can be modified. And it's modified by replacing, very simply, a little mechanical cam, and you get two alternative cams with this as it ships, and there is a third one you can buy. I'm using the default cam 4 profile, and that's designed to pretty much represent the feel of a general aviation aircraft, with a compromise to make it slightly more relaxed towards the extremes. The pedals also come with a number 6 cam, which is designed to mimic the profile of an airliner, where the control surfaces are generally not directly connected to the rudder pedals. And there is a third cam that you can buy currently, which is called cam 5, and that's billed as the realistic general aviation profile. The difference being out towards the extremes, the tension goes up very significantly, and so you're definitely going to need your chair screwed down for that one. Now the other thing you're going to find, and hopefully you'll see it on this graph, is that the amount of force required to operate these devices varies significantly across these three controllers. The Flight Link pedals need about 17 kilos of force to achieve full deflection, which is almost 3 times what the Cytec pedals need. The crosswind pedals are again adjustable, but they're pretty much comparable to more comparable to the Flight Link pedals than to the Cytecs. Now the Cytec pedals do have a tension adjuster, which is supposed to give you some variation. In practice I've found this makes almost no detectable difference, and the measurements that I've shown here were all made with the tension dial turned up to maximum. The MFG crosswind pedals have, again, adjustable tension, which does seem effective. For the measurements shown here, I had this set about halfway. Something you won't see here, but something which makes a real difference in realism but also in the feel of the pedals, is damping. Now, damping mimics the effects of, I suppose, inertia, but also the effect of sweeping the rudder sideways through the air. And of these three controllers, only the flight link pedals have any damping, and this is achieved using oil-filled pistons, rather like, or in fact exactly like, the shock absorbers in your car or in the suspension of a mountain bike fork, for example. And these make a big difference to the feel of the pedals, because what they do in practice is it resists sudden, rapid changes in the position of the pedals. So that's the mechanical characteristics, but we also need to look at what electrical values the controllers output to FSX. Now, in a real aircraft, particularly a general aviation aircraft where the control surfaces are connected directly to the rudder pedals, the displacement of the control surfaces varies more or less linearly with the displacement of the pedals. In a simulator, of course, there is no such direct connection, and all manner of transformations can happen in between. Now, as far as I know, each of these controllers, like most controllers for flight sims, use linear potentiometers or linear components, although potentiometers do come in other variants, notably logarithmic or anti-log, or I think exponential variants. So what this means is that, assuming our pedals have linear components, we'll get an output that varies linearly with the position of the pedals. Now, this may or may not be what we want. For example, it's generally considered that for helicopter controls, a logarithmic curve more correctly models the behaviour of anti-torque pedals, and that means that the pedals are much more sensitive around the central point. So for small movements of the pedals, you get a large deflection of or a large increase in the anti-torque response, whereas out towards the extremes the response sensitivity drops off. Now, depending on what software you use behind FSX, you can get some control over how the inputs from the rudder controller are transformed before they're sent to FSX. If you use the Cytec SST software, for example, that gives you some control over the shape of that mapping curve. I haven't tried that, but you can certainly do it with FSU IPC on all of your analog axes. So FSU IPC allows you to modify the curve for each axis independently, and you can modify the curve from its default linear shape to have a logarithmic or an exponential shape to varying degrees. So you pretty much should be able to get what you need. Now, there's something else you need to be aware of here, which is that FSX also messes with our analog axes. FSX always applies an exponential transformation to the controller inputs, which for the rudder means that it gets more sensitive as we move it away from the centre. Now, also, depending on the position of the sensitivity slider in the FSX controls dialog, FSX limits the rate at which any rudder deflection is applied. And this sort of simulates damping, if you like. If we were to set the slider to maximum, we get essentially maximum damping, which means even if we abruptly kick the rudder out to one side, it doesn't immediately change. There's a delay in how quickly that input is applied. Now, this all gets very complicated, and I'm not going to cover it in detail here. I might do a separate video on this, in fact. But what I would suggest, ideally, is, assuming you have FSU IPC, if you go into the FSX controls dialog and uncheck the Enable Controllers checkbox, that cuts FSX out of the loop altogether, and you can safely ignore that. So what else do you need a rudder for? Well, pretty much anything aerobatic is going to involve deliberately flying uncoordinated manoeuvres, and we'll just look at a simple one here. So we're going downhill fast in the Piper Cub, and we're going to pull it up to the vertical before kicking the rudder hard over. Now again, this is an unsubtle control input that any of these controllers can manage with ease, but there are plenty of manoeuvres that require more subtle rudder inputs. I'm just not very adept at demonstrating them. We're going to have a look at one last scenario where the rudder is essential, and that's a crosswind landing. Now we've switched over to the Real Air Decathlon for this. In my experience, this is one of the very best aircraft to demonstrate a crosswind landing. The Decathlons also, indeed like the Scout and the Citabria that come in the same package, it's also good for practicing your coordinated turns in. These aircraft are quite squirrely, if you like, and there's noticeable adverse yaw. But for our present purposes, it's an aircraft that side slips beautifully. We're going to use that for a classic wing down approach. We'll keep it in a crab until we get close to the runway threshold. The crosswind's from the left here, obviously, and then we're going to swing it straight on the rudder and drop the left wing to stop it drifting. Now this is another situation where you really appreciate the fine control around the centre position, and so the Cytec falls behind again, although it will handle it competently enough. I do like the flight link pedals here because that oil damping really makes it feel like you're pushing against the air, but the MFGs really have the edge on subtlety, and this is not down just to the mechanical engineering. The MFG rudder uses a 12-bit sensor, which means it has 8 times the resolution of the Cytec pedals, and because that sensor's contactless, it's not going to get dirty, and so you're not ever going to get any spiking from that. Now I don't have the Flight Link USB interface. I have my pedals piggybacked off a Logitech joystick controller, but Flight Link sells a range of 12-bit interface boards, so I think it's safe to assume a 12-bit interface for those pedals as well. If you have their interface, you could plug it into something else like a Leo Bodner controller board, which would also give you a 12-bit interface. And of course the potentiometer in that thing's an industrial grade pot that's rated to over 1 million revolutions. So how do these things stack up, and are they worth buying? Well, the simple fact is that adding any of these controllers to your flight sim setup is going to increase the realism factor. That said, at the low end we have the Cytec ProFlight, so-called ProFlight rudder system. And again, I think it's only fair to point out that the use of ProFlight in the name of these things is very dishonest. You know, these things are in no sense professional quality equipment, and that's reflected in the performance. You know, there's two main critiques I think I have of the Cytec. One is the central notch. You know, this is a well-known issue with Cytec controllers. There is a very solid central notch that you have to kick this thing in and out of before you can do any control, and that really gets in the way of fine control, and it's kind of amplified by the other main criticism of the Cytec pedals, which is that they don't have very high mechanical resistance. Now, bearing in mind that we operate these things with the longest, most powerful muscles in our bodies, our leg muscles, the Cytec is just too sloppy, and the adjustment dial in the centre of the pedals for me makes very little difference, or what little difference it does do, it doesn't make the variation from minimum to maximum is slight, should we say. And in practice all this adds up to, well, I was going to say two things. One thing, getting fine subtle control with the ProFlight pedals is very difficult. It'll do fine in the things where you just need course control, so keeping it straight during the takeoff roll. Arguably doing the crosswind approach does a good job as well, but flying coordinated turns in the glider, things of that nature, there's certainly the timed turns that we looked at, doesn't really achieve very good performance. That said, I've had this controller for 6 years now and it's continued to work. The pot hasn't noticeably worn out, it doesn't give spikes. So if you're on a budget, by all means get one of these. Let's zoom to the other end of the scale, Flight Link. The Flight Link pedals, Again, I really like these pedals. They're nothing about them is adjustable, but that said, you know, they don't need adjusting. Very high resistance out of the box in terms of the sheer amount of force required, and we can guess that this is realistic simply because this is a professional, this is truly a professional grade product. You know, with no need to brag about it in the name. These things are put in genuine aviation training devices, and they do a superb job. You know, the feel is great, particularly the damping. I think where this scores is the damping. It means you can't just slam this thing around lock to lock willy-nilly, which you can with the Cytec pedals and to some degree with the crosswind pedals as well. You know, that sense of damping really makes you feel that you've got some big control surface on the end of a couple of wires that you're sweeping around in the airflow. And also, you know, if you're flying something like DC-3, for example, that's a pretty hefty chunk of weight on there as well. It'd be an aluminium frame, or it might even be a steel frame, although it would be fabric covered. If you want to buy one of these new, obviously you have the choice of the anti-torque pedals or the RCS, which is in a different package and includes the toe brakes as well, modelled after the kind of Cessna style, I believe. But you're looking at something like £800. This is British pounds, not even dollars, to buy something like that. So the MFG crosswinds, how do these stack up? Well, these are kind of the new kids on the block, if you like. There's a lot of buzz about these out on the internet, and they're kind of slap bang in the middle of the price range. They're made by an outfit called the Milan Flight Group. Well, actually Milan, they're just not Milan in Italy, it's they're made in Croatia by a guy called Milan, he's probably Milan Simonza, I believe. And they cost me €350, including shipping. That's about £250. And just looking at the things, you know, they're an engineering work of art, really. You know, they could, if they didn't fly flight sim, they could be used as a piece of sculpture quite passively. Look like something out of a spaceship. But they are, you know, beautifully engineered, completely adjustable in many dimensions. So as we've seen, just to recap, the tension is adjustable. The actual mechanical profile is adjustable by substituting cams. The position of the pedals is adjustable in several dimensions, and so on. I'm not going to go on about this. It's probably worth pointing out as well, in terms of longevity, this controller uses exclusively contactless sensors, not potentiometers, so they're not going to wear out and start spiking. But coming back to usability, of all these three controllers, it has the smoothest operation. You know, in terms of the central notching tendency of the Cytec, for example, I mean, I didn't mention that the FlightLink doesn't have that either. MFG pedals can have that to a greater or lesser degree, depending on the cam profile that you have fitted. I've been using the standard cam 4, that has virtually no detectable central notch at all, and yet the pedals do centre assertively. But what you can do is you can rock them backwards and forwards in and out of that central position with almost no discernible notching tendency, and that's really, really important in getting subtle controls, particularly of the coordinating of gentle turns, shall we say, which is kind of crucial if you want to fly precisely. And it has just such a nice feel to it. You know, it's beautifully smooth throughout the range. The one thing I would, you know, it would be nice if it had some damping in there. Don't know how they would do that, you know, in practical terms. So which one should you buy? Well, at the end of the day, this is not really an unconstrained choice. This is going to come down to price, what you're prepared to pay, what you can afford. You know, the entry level, the Cytecs cost about £100, between 100 and I think the official price is now £100, and that's comparable to the competitors, I suppose, the only other competitors at that end of the range, which are from CH products. They're again CH Pro pedals. I've never tried them, so you know, they may be better or worse than the Cytecs. Cytec also does two other models in its range. It has a thing called the Pro Flight Combat pedals, which look, I mean, I've not tried these again, you know, so you know, you need to do your own research. It looks to me like it's the same mechanism, but the actual foot pedals are different. There's some aluminium used in there, which, you know, to me is irrelevant, but the angle of the pedals is different. I suspect it's exactly the same mechanism. The price of the combat pedals, I think officially, is £160. Now Cytec does another variant of its so-called ProFlight pedals, and this is the one that's branded by Cessna. Now again, it looks from the outside to use the same mechanism as the basic ProFlight pedals, but the actual pedals are different. They're more Cessna shaped. Now it's possible that this is actually a different mechanism inside, and I'm saying that because I've recently discovered that the ProFlight yoke and the Cessna ProFlight yoke are not the same inside. They look the same on the outside, apart from the yoke handle, and of course inside they are similar, but there's a completely different aileron mechanism. I've only seen photographs of it, but the construction is also looks heftier and with some metal components in there. So it is possible that in order to win that Cessna badge, Cytec has had to up its game. The price, again, I think officially looks like £150, £160. If you fly different kinds of aircraft, you know, one of the ways that the MFG system scores massively over all the other pedals I've seen is this adjustable mechanical profile. And you know, if you read the documentation on their website about the cams, really the whole point is that you can chop and change depending on what kind of aircraft you want to fly. So if you want to fly general aviation, airliners, combat, sailplanes, you can choose a cam profile that's specific to that application, and you can swap it in and out in about half a minute. And that's really, you know, an attractive option, I think. You know, the kind of aircraft I fly routinely are, we've been looking at the Piper Cub today, the ACA Scout and Decathlon. I'm starting to experiment with the gliders, and then of course the Twin Otter I fly a lot. You know, they're very different aircraft, and being able to change the feel of the rudder, that's a really attractive option. So there it is, rudder control systems for flight sim. Low price, mid price and high price. At the end of the day, you know, look at how much you can afford, what you need. But I would definitely recommend getting a rudder control system of some sort, and if you want my advice, hold out for the MFG crosswind pedals. There has been a waiting list for these up to recently, but the latest news is that they're ramping up production and they should be available from stock from about now.